Coterminal angles. This is still lesson 1, radian and degree measures, but this is the second half of the lesson. So if you want to take a break, you could. Coterminal angles are simply angles with the same terminal side. They are coterminal. They end in the same place. Okay? They start at the same spot, they ended at the same spot. The difference is the number of times they went around the circle. So for example, 30 degrees. Well, 30 degrees. Here's this. 30 degrees. That'd be something like about here. Okay, that's 30 degrees. 390 degrees is right here, but to get there I had to go like this. So I had to go all the way around, which is 360 plus another 30. 750 again. 750 is also right here, but now I'm going to go around once, twice, and then hit there. So coterminal angles, they're all starting at the same place, but they're also ending at the same place. The fact they're ending at the same place means they are coterminal, terminating in the same location. Now, sometimes you're asked for a positive coterminal or a negative coterminal. Other times you're asked for all the possible coterminals. Well, that simply means your angle measure, in other words, in this case, 30 degrees plus, and then you just put K or N or whatever, 360 degrees. This means where K is some integer. It could be going around once. It could be going around negative once. Whatever it is, it's going all the way around the circle some number of times. That's what coterminal is. So, down here, if I want to find a positive and a negative coterminal angle for the following. Well, for a positive coterminal angle, I'm going to take 60 degrees and I'm going to add 360 degrees to give me 420 degrees. That's a positive coterminal angle. I took my 60 degrees, which is here, and I went all the way around and got back to it again. Now, if I want a negative, I'm going to take my 60 degrees and I'm going to subtract 360 degrees. Well, remember that subtraction or negative simply means I'm going to take this number and I'm going to go in the clockwise direction. So 60 minus 360 degrees is negative 300 degrees. It's saying if I actually start at the x-axis, I don't have to go around negative 300 degrees. Okay? So you add and you subtract to get to other coterminal angles. You may have to add 360 a couple of times to get to a positive number, or subtract 360 a couple of times to get to a negative number. Let's try this next one. 100 degrees. Well, 100 plus 360 is equal to 460 degrees. You must put the degree symbol. Without the degree symbol, one may think it's radians. To get a negative, it's 100 minus 360, and that's negative 260 degrees. 100 degrees, 460 degrees, negative 260 degrees are all coterminal. We start at negative 200. Well, negative 200 plus 360 is equal to 160 degrees. There's a positive coterminal angle. 160 degrees ends at the same spot as negative 200 degrees. If I want a negative coterminal angle, negative 200 minus 360 is equal to negative 560 degrees. There's a negative coterminal angle. There are an infinite number of coterminal angles. That being said, on a test or quiz, I am asking you to find the nearest coterminal angles. Do not do something crazy like, 13 times 360 plus this angle. I'm not going to figure out if you are, I'm not going to take the time with close to 100 students, plus or minus some, to figure out everybody's different answer. Please just add 360 or subtract 360. And you might have to do it twice to get to a positive or a negative, but don't do crazy things. Okay? Negative 50 degrees, negative 50 plus 360 is 310 degrees. If I want a negative coterminal angle, I'll do negative 50 minus 360 is negative 410 degrees. Coterminal angles, angles that end in the same location. They all start at the same spot. Radians. Ooh, what is a radian? Angles may be measured in radians instead of degrees. It's like saying I can measure a trip in miles or kilometers. Right now, you guys are more comfortable with degrees and used to degrees. Eventually, there are certain operations where radians will make so much more sense. I know, not right at first, but eventually. So, to explain what a radian is, we're going to take a circle with a radius r and an angle with its vertex placed at the center of the circle. So here's the center of my circle. R is equal to the length of the radius. S is the arc length. Theta is the angle in radian measure. Now, very important, theta is equal to S divided by R when theta is in radians. When theta is in radians. Theta is in degrees. This little thing here doesn't hold true. When it's in radians, the arc length divided by the radius is equal to the angle. That's important. Okay? Why? Because then we can do very quick and easy things. Example. If I know that the radius of a circle is 10 and the arc length is 6, I can find out the degree of the angle. I simply do theta, let's do something in a better color than that. Theta is equal to S over R, which is 6 over 10, which is 0.6, or 3/5. Now, you don't put degrees on this because this is radians. Radians, you don't put any mark. There's no mark for radians, okay? So just leave it alone. All right, let's try this next one. Oops, I thought I had another one down here. I guess not. Okay, degrees and radians. So theta is equal to S over R, the length of subtended arc over the length of the radius. That's official mathematical speak, okay? Now, if we place a circle on the XY plane with the circle center at the origin, which is 0, 0, and we want a radius of 1, that means out here, this is 1, 0. Up here, this is 0, 1. Okay. Out here, this is -1, 0. Down here, this is 0, -1. Those are the points. Just if I did it around because the radius is 1. Now, the circumference of a circle is 2 pi r. 2 pi r. That's how we find the distance all the way around the circle. All right? Erase this real quick. Just clean it up. Now, for a unit circle, and we call it a unit circle because the radius is 1, the circumference is 2 times pi times, oops, okay, I can't make a 1 like that. Let's just make a 1. Circumference is equal to 2 pi r. R is 1, so 2 pi times 1 is just 2 pi. That's the distance all the way around, and I'm leaving it in terms of pi. I'm not asking you to multiply out 3.14159 times 2. Okay? It's 6 point something, 6.2, blah, 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 blah. Arc length is equal to S. And arc length all the way around the circle, if I go all the way around the circle, that's an arc length, is just 2 pi. So S all the way around the circle is 2 pi for my unit circle where the radius is 1. Theta then is equal to 2 pi divided by 1, or 2 pi radians. Well, we just said that 360 degrees is how big an angle is all the way around. Here we just calculated that all the way around it's also 2 pi radians. Great. Well, if we want to convert back and forth, just like from inches to centimeters, centimeters to inches, we want to do conversion. I want to know what 1 degree is equal to. Well, if I change this so that it's 360 divided by 360, and this is divided by 360, I wind up with 1 degree is equal to pi over 180 radians. I now have my conversion. So if you give me some number of degrees, 2 degrees would be 2 pi over 180. Okay? So I can figure out degrees to radians. What if I want to go the other way? Well, remember that we have 360 degrees is equal to 2 pi radians. So here, if I divide this side by 2 pi, that will give me 1 radian. I have to divide this side by 2 pi, and I get 180 over pi is equal to 1 radian. So 1 radian is equal to 180 over pi degrees. If you know this, you can go back and forth between degrees and radians. Now realize that 360 degrees goes all the way around. 2 pi radians. 2 pi is 6.2, on and on and on. So degrees splits the circle up into angles, into 360 angles. Doing it in radians, it's a little over 6 divisions. Okay? Now, if we want to simply convert 60 degrees, well, this is where we have to remember our conversion ratios we found down here. I know some number of degrees. I'm going to multiply by pi over 180. So 60 degrees by pi over 180. 60 goes into itself once, into 180 3 times. This is pi over 3 radians. 45 degrees. Multiply it by pi over 180. Simplify this. 45 goes into 180 4 times. 45 degrees is pi over 4 radians. 300 degrees. Again, I simply multiply it by pi over 180. Remember, radians is just a different way of measuring degrees. You can measure a distance in inches or centimeters or feet or meters or miles. And to go from one to the other, you have a conversion ratio. That's all this is. Okay, so here you've got 300 times pi over 180. Okay. And you can simply, one of the first things I would do is say, I can get rid of my zeros. Now, without a calculator, you could think of it as 30 pi over 18. What goes into 30 and 18 evenly? Because I do not want to see decimals. I want to see it stay as a fraction. So 6 goes into both evenly. And you get 5 pi over 6. Do not give me decimals. 125 times pi over 180. You should notice that 125 and 180 are both divisible by 5. And so you can do 5 will go into 125. Oops, ouch. 25 times. 5 will go into 180 36 times. So you get 25 pi over 36. Okay, going from from degrees to radians, multiply by pi over 180. Now, what if we go the other way? Well, we're going to multiply by 180 over pi. And the nice thing here is the pi's will cancel. But before you just say 360 over 5, please do 180 divided by 5 is 36. So now you're going to get 36. 2 times 36 is 72 degrees. Multiply this by 180 over pi. It's my conversion ratio. I'm going 2 degrees. So you want the degree on top. Pi's cancel. 4 goes into 180 45 times. 45 times 3 is 135. 11 pi over 6 times 180 over pi. Always nice, those pi's cancel. 6 will go into 180 30 times. 30 times 11 is 330 degrees. Pi over 3 times 180 over pi. Pi's cancel. 3 will go into 180 60 times, so pi over 3 is 60 degrees. Converting between radians and degrees and radians. It's just another way of representing an angle. It's a different measurement. Okay, now here's a couple of these. Go ahead and try doing the conversions. Pause the video and try doing these conversions and then come back. Did you pause the video? I hope you did, and I hope you tried it. Okay, remember that the negative is important because it indicates direction. So all I'm going to do is multiply negative 2 pi over 5 times 180 over pi, and I'm going to get negative 72 degrees. For radians to degrees, this gets a little weird because I'm going to multiply by 180 over pi. And here, this is the only time, and if I ask you to do this, I would give you a calculator, okay? 229.183 degrees. When you're doing degrees, just don't leave pi in the denominator, okay? And don't have some crazy huge number, just simplify it, okay? So this is definitely a calculator problem. Otherwise, you would just do 720 over pi, and that would give you the 229, okay? Without a calculator, you could give me this. With the calculator, get it down to decimals when you're talking degrees. Converting 135 to radian measure, this is going to be pi over 180 is what I'm going to multiply by, and you should have gotten 3 pi over 4. Negative 30, don't forget the negative sign. Multiply it by pi over 180, and your answer should be negative pi over 6. Everybody crushing it? I hope so. All right, try these. The number of radians in a complete rotation is approximately 6.28. It's 2 pi, and then if you do 2 times 3.14, that's how we got the 6.28. So when it said approximately, that's so that you can sort of think of it as a number. Now, if I want to find the centimeters, find in centimeters the length of an arc, that means I'm going to want it in decimal form, okay, of a central angle of 4 radians and a circle with a radius of 3.5. For this one, remember that theta is equal to S over R, but theta has to be in radians. If it's not in radians, you need to make the conversion. So find the length in centimeters of the length of an arc. So I don't know S. Okay. Intercepted by an angle of 4 radians has a, oops, 4 radians, got a little, boop, back here, with a radius of 3.5. So you just multiply both sides by 3.5 and you have 14 centimeters. In a circle, a central angle of 1/3 radians, okay, so 1/3 radians, there's my R, subtends an arc of 3 centimeters, there's my S. Find the length in centimeters of the circle. Well, theta is equal to 3 divided by 1/3. 9 centimeters. Not hard, right? Okay, remember both of these, you were given the angle in radians. What happens when you are given the angle in degrees? Uh-oh, dun, 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 dun. You got to convert. Got to convert. So, a sector has a radius of 12 centimeters. So, R is equal to 12. And an angle of 65 degrees. Theta is equal to 65 degrees. Ooh, but I need it in radians. So, this is going to be pi over 180. You have to convert it. Oops, put a little multiplication symbol in there. You have to convert theta to radians. If you don't, you are not going to get the right answer. And that is probably the biggest mistake that most students make. So when you do this, you're going to wind up with 13 pi over 36. That's what theta is. So now you want to find S. I'm going to give myself a little more room. S is 13.6. How did I get that? Well, I have 13 pi over 36 is equal to S over 12. If I multiply both sides by 12, I'm going to have 13 pi over 3 is equal to S times 12 times 12. And then I simply convert the pi to 3.14. This is again something that you would need to use a calculator with because, well, let's face it, you wouldn't tell somebody to run 13 pi over 3 or to cut a board 13 pi over 3 centimeters. You would actually tell them 13.6 centimeters, all right? So when you're talking about linear distances, put it in decimals. Otherwise, if it's a radian degree, I want it in terms of pi and as a fraction. In summary, positive angles rotate counterclockwise. Negative angles rotate clockwise. Coterminal angles have the same initial and terminal sides, but differ by a product of 360, where n is an integer. Angles can be given in radians or in degrees. Angles measured in degrees can be given in decimal degrees or in degree, minute, second format. Don't forget that 1 degree is equal to 60 minutes. 1 minute is 60 seconds. Okay, and think of a degree as an hour. Okay, 1 degree is equal to 60 minutes. 60 seconds per 1 minute gives you 3,600 seconds. Do your conversions. Just change things to fractions. Theta is equal to S divided by R, where S is the arc length and R is the radius. Theta is in radians. Notice that's in red. It's in radians. If it's not in radians, convert, convert, convert. 1 degree is equal to pi over 180 radians. 1 radian is equal to 180 degrees over pi. A radian is simply a different measurement for angles. Okay? That's it.